Hello minions, it's MoNaCo here.
And milks.
We are
Moving along. Acids and bases.
video number 5.
Ooh, page 11.
And
How strong an acid and base is.
yeah, how strong it is.
Of course,
Relative strengths of acids and bases.
Of course, we measure this in pH.
Which you should be familiar with.
Right, and we're going to, of course, take it a little bit deeper.
Gotta go
That's
another
how we do
step
it in
beyond.
chemistry.
Got to.
That's how we do it.
So, good old-fashioned pH scale. What you got here, Mr. Milks?
What we already know.
Neutral, pH 7. Got it.
Acid, smaller than 7.
Okay. Base, greater than 7. Beautiful. Simple enough.
What we might not have known is strong acids dissociate completely. So dissociate is those ions breaking apart in solution.
Completely.
And completely is every molecule of acid that went in breaks up.
Absolute.
No man left behind. They all break up.
When we did our solutions, Pogel, you saw salts that did this. So, like NaCl dissociates completely.
Yep. And
There's
so does,
no Na bound to Cl anymore.
correct.
This type of acid would dissociate completely.
And therefore, I get a pH range of 0 to 4 because my concentration of H plus is going to be really high.
Right. Weak acids are the types that we're going to run into in our food and diet a little more often. These do not dissociate all the way. So this would be the scenario where some of the hydrogen atoms are still bound to the molecules that it came in with, the spectator ion. So the pH range is closer to 7. So the closer you get to neutral, the weaker the acid is.
Good. Now, strong bases, just like strong acids, dissociate again completely. The OHs all leave the metal that it was bound to, and I have lots of OH in solution, so my pH range is now going to be between 11 and 14.
Cool. Now, weak bases, just like the weak acids, incomplete dissociation. The closer you are to pH 7 neutral, the weaker the base is. Okay, so the further away you are, you're at 1 or 14, strong acid, strong base. You're close in to 6 and 8 or so, weak acid, weak base.
Sure.
But that's something that isn't too hard to relate to.
And we might already know about.
So let's go on to the next step. What the heck does pH value relate to?
Ooh, my nemesis, logs. It is
Logs.
specifically the negative log of the H plus concentration in solution.
Right. And concentration in solution is measured in molarity.
Right, so the molarity of the acid, of a strong acid,
How much solute acid is dissolved in a solvent, water,
dissociates completely. That is the number we put in here.
and you take the negative log of it, and it gives you the pH number.
Right, good thing we got a calculator for this.
Yeah.
And the way it works is, the higher that concentration works, the lower the pH value.
Yeah.
The lower the pH value I get as an answer.
So the more H plus you've got, the smaller the number you get out after you do the negative log.
Right, and notice we're consistent. There's an H3O plus in there, that hydronium ion, remember that's the same thing.
We mean the same thing. So what it really means is the logarithm is a base 10 scale.
Right.
So every 1 unit corresponds to a 10 times change in concentration when we're talking about pH.
Okay, good, let's practice that.
Yes. Yes.
Next piece. So I'm going to narrate. Going from a pH of 4 to 5, I am becoming more basic. Because I'm going closer to 7. I'm going away from the acid side, so I'm becoming more basic. Therefore, my OH concentration must increase. And because I'm only moving one spot on a pH, it's going to be times 10. Notice he put a 1, 10 to the 1. So 10 times
10 to the first is
10.
10. And that 1 is the number of spaces that you jumped.
Correct.
1 space jump, base 10 logarithm, 10 to the first, 10 times.
All right. Now, same change, but in relating it to acidity, I'm becoming less acidic. Therefore, my H plus concentration must be going down. But my pH change was the same, so this is also going to be a jump of 1, which is 10 to the 1, which is a 10 times change.
10 times change. So the thing to remember is that each pH number change, so from like 5 to 3, you go, wow, that changed twice. So that's 10 to the 2. 10 squared, 100 times. It's like 10 times 10. Not just 10 times 2, 20.
Yes.
People are going to mess that up.
Most common mistake.
10 times 2. Or is it 2 times more? Or 3 times more?
No.
It's 10 to the power of however many steps you took.
All right, good. This example, I'll bang it home a little bit. So as I go from 13 to 10, I'm actually going away from the basic side, and I'm becoming more acidic. So that means my H plus concentration must be increasing, and I'm moving a pH of 3, so that's 10 to the 3. So that's 10 times 10 is 100, times 10 is 1,000. So my H plus concentration just increased by 1,000 times.
Not 3 times, not 30 times, 1,000 times. If you could count all of the hydrogen ions in there
There'd be 1,000 times more,
at a pH of 10 compared to a pH of 13.
specifically. Okay, so the opposite's going to happen now for basic. I'm moving away from the basic side, so I must be becoming less basic. Therefore, my OH concentration is decreasing, and I still move 3 spots on my pH, so it's 10 to the power of 3, which is going to be 1,000 one more time.
And one more little piece of knowledge for you. pH itself stands for the power of hydrogen.
Yes.
So that exponential power is what it's all about.
Hence logs.
Logarithms, powers of 10, etc., etc. So know how to jump and use your calculator. Basically, you got to count and be able to multiply times 10 to the 4th, 5th, 6th, 7th, 8th,
Sure.
14th, whatever.
And very rarely do we actually give you the concentration. You got to do negative log.
Never
Most
on the
of-
regions.
Yeah, most of it is the pH changed from
How
this to
many
that.
times did it change?
There
How
you
much?
go.
How much more acidic is it?
There you go.
10,000, 100,000, whatever.
There you go. So that's it, guys.
Yeah.
Understand the theory of pH and know how we relate the concentration of H plus to our pH changes.
A lot of good reading and practice in the pack related to this concept, even though we covered it very quickly in the video.
Yeah, because we
This
really
is a
need to know.
hands-on math thing. You got to be able to see
This
it
is
in the
it.
decimals and all that place. That's what's up.
This is what we're going to see the most on the regions. This and the indicators next video.